And here we go with problem number 3. So here's your time and your velocity data. Notice we're starting off very high velocity. We're going fast, but we're slowing to a stop. And that is motion we want to understand. Going fast and slowing to a stop. So here's our, first thing you had to do is graph it. So here's part A. So you start off with a starting velocity, of 10 meters per second. And it looks like we're slowing down at a steady rate until we get to 0 over here. And now we want to write the mathematical model for it. And look at this. They labeled their graph velocity with units, time, and seconds. Nice. And it's all nice and straight and neat and well incremented. Good job. Then here is the Crutch equation. I like it. Instead of y, what's the vertical velocity now? I'm sorry, the vertical axis is velocity, use the letter v, equals. Now look at the slope here. It looks like every second we're dropping by 2 meters per second. So we our rise is really a drop, so we make it negative. We decrease our velocity by 2 meters per second every second. So it's negative 2 meters per second every second. And that's a meter per second right there. Now you can, by the way, it's okay to call it meters per second squared. It's just a little bit easier to write. But this is what it means. This is what's happening. I don't know what a square second is. Times time, because that's my horizontal axis, plus b. Now this does have, like the last one we did, our starting velocity was, it was 2. It was 2 meters. Anyway, what is our starting velocity? At time t equals 0, we're going 10 meters per second. So this is my mathematical model. Now part C, I want to create a data table that explains how far I've changed my position after each second. Remember, at 0 seconds, I haven't had time to go anywhere. So I have gone 0 displacement. Now at 1 second, how far did I go? Well, look, I started off going 10 meters per second. If I had gone 10 meters per second for that whole second, I would have gone 10 meters. But I dropped in velocity. So it's like I'm taking away area. That's one way of looking at it. Or you can say, look, at the end of the first second, I was going 8 meters per second. So if I'd been going 8 meters per second that whole time, I would have gone 8 meters. But I started off going faster than 8 meters per second. So this little area represents how far I went because I was going faster at the beginning than I was at the end of that time interval. Yes? Okay. So how far was it? Well, this is 2 times 1 is 1. Right? That's 1 meter, just like the last one. So 8 plus 1 meter is 9 meters. I want a total of 9 meters in that first second. But I am slowing down. So in the next second, well, at the end of second 2, I was going 6 meters per second. 6 meters per second times 1 second is 6 meters. But I started off going 8. So I went a little bit of a distance because I started off going faster. So that's 1 meter. All the triangles here are 1 meter. So 6 meters plus 1 meter is 7. 7 plus 9, that's 16. And then look what we got here. 2. So we end up going 4 meters per second. For 1 second, it's 4 meters, but I got to add a little bit because I started off going faster. 4 plus 1 is 5. 5 plus the 16 I had before was 21 meters. So the total, 21 meters. All this is 21 meters. The next second, I end up going 2 meters. And then plus the 1, I had 3. That's 24. And then you have 1 little meter right there. I stop here, but I started off going 2 meters per second. So that's 1 meter of displacement, which gives me a total of 25 meters. Does that make sense to everybody? Okay, so what is, now I can check to make sure I did this right, because what's the whole total area underneath here? Well, it's 1/2 the base times the height. Base of 5, height of 10. 5 times 10 is 50. divided by 2 is 25 meters. You can always check that. Check your answer that way. Okay, next we had to graph that. So all we do is graph, for these times, graph these displacements. And, oh, geez. Pick one. You have one that's horizontal? Yeah. So here's different groups because theirs fits a little better on the land. They did it landscape. And here we have the position as a function of time. We'll say position because our initial position, we'll say it starts at the origin. And as a function of time. And notice that it is a parabola. Well, what kind of parabola is it? It's a parabola that bends down like this. Now, the only thing I would say is at 5 seconds, I'm going to improve. Do you have your dry erase for me? Or that? I'm going to change this a little bit. At 5:25, it should have like a 0 slope. So this slope right here at 5 seconds. Oh, sorry, my face is in there. This should have a 0 slope because we have 0 velocity. And that's what it looks like. And again, these graphs should be big and very neat, and those accurately plotted and make a nice curved shape. Don't draw line segments between the dots. Make it a nice curved shape. Does that, any questions on that? Excellent. That is all.